Adding a new formula to Wikipedia. Okay, these first three formulas, all of those I found it in Wikipedia, right? And also they needed something known as a principal value and stuff like that. But yeah, like in this video, I'm just gonna do the last one, right? And the last one is also pretty interesting. There's some zeta functions involved, but the answer is pretty simple, just a log of 2, right? And with a negative sign. So seems pretty cool. And do check out Wikipedia if you want like the similar formulas that you might want to prove. But this one is completely new, right? And this is interesting. So let's prove this. We have sum from k equals to 1 to infinity 1 minus zeta of 2k by k, right? I can write this as sum from k equals to 1 to infinity of 1 by k, right? Now I can write 1 minus zeta of 2k as like sum from n equals to 2 to infinity, because the first term in the zeta will be cancelled by 1 and then all of them will have negative signs, so I just write negative sign over here. In 1 by I will have n to the power 2k, right? So I'm just invoking the definition of zeta function. Now I take k inside that sum, right? Sum from n equals to 2 to infinity of 1 by k n to the power 2k. And now I introduce the sum. Sum goes from now n equals to 2 to infinity, and sum from k equals to 1 to infinity, and 1 by k n to the power 2k. Now the reason I'm doing this is because now I can use the log, right? So what I can do is I can actually write this as, because there's negative sign. Okay, well, first of all, let me write this as sum from k equals to 1 to infinity of uh, 1 by n square to the power k by k, right? Now, since the modulus of 1 by n square is less than 1 when n goes from 2 to infinity, so what I can do is, also there's negative signs, so I can use them to write it as a log, right? Log of 1 minus 1 by n square. Okay, now how do I simplify this further? So I'm gonna like invoke integral. I'm gonna involve integral over here now. And how I will do that is I can actually write this as this log 1 minus x square by n square. I'm writing x square so that it becomes a bit kind of symmetric and like that, right? And this from 0 to 1, right? Because yeah, I'm just evaluating this from 0 to 1, and it just simplifies to the same thing, because at 1 this is log of 1 minus 1 by n square. At 0 this is 1, just 1, and log of 1 is 0, right? The same thing. And now I can actually write this as integral from 0 to 1 by taking the derivative. If I get derivative, I will have 1 by 1 minus x square by n square times minus 2x by n square, right? Now if I multiply that with the expression, I will have sum from k equals to 2 to infinity integral from 0 to 1 minus 2x by n square minus x square dx, right? Now I can use partial fraction, also introducing sum and integral. If I use partial fraction over here, I will just get 1 by n minus x? No, yes, no. Plus x minus 1 by n minus x. If I use this, I will have, yeah, n minus x minus n minus. Okay, yeah, exactly. Yeah, this is the partial fraction decomposition. Now I gotta tell you something. There's this thing called digamma function of g plus 1, which is negative of other Masonic constant plus sum from n equals to 1 to infinity of 1 by g minus 1 by n plus g, right? Using this definition, you can actually prove that sum from n equals to 1 to infinity of 1 by n plus g minus 1 by n plus x, let's say. This sum is going to be equals to digamma of x plus 1 minus digamma of g plus 1. We can actually prove this from this definition itself, right? And actually, I think I should be leaving it on you to prove that, because it's just some manipulation, some addition of terms over here, and there's nothing more. Yeah, you can try to prove this from the definition of digamma function. And also, there's a thing that this digamma is actually the derivative of the log of gamma function, right? You can also see why this works. I mean, you can just Google it and then, I mean, like, it's actually defined this way, right? Yeah. Okay. So, now based on all the information I gave you, if this sum was going from 1 to infinity, it would have been easier, but it's going from 2 to infinity. First of all, just assume it's going from 1, and then so this will be 1 by minus x plus 1 minus digamma of, you will have x plus 1, right? And now subtract the first term. First term will be minus 1 by, okay, there's something not good over here. This sum is in terms of k, but the variables are n. Okay, it seems like I messed up somewhere over here. Okay, this is answer to the power k. Oh, this sum was in terms of, okay, I know it might have caused you some problem, but I'm sorry, guys. This always happens with me. Okay, okay. Now, yeah. So now, if I subtract the first two terms, okay, this one will just be x plus 2 and then plus 1 by 2 minus x. So what I did was I just evaluated the sum considering n as 1 first, and then I subtracted the first term because it actually goes from 2, right? 0 to 1. So okay. So now what can I do? Okay, so over here I have digamma of 1 minus x, and then plus I have digamma of 1 minus x plus 1, right? Similarly, I have minus digamma of 1 plus x, and then I have here plus 1 by x plus 1 plus 1, right? Okay, so that's what I have, and from here we actually I should tell you that digamma of like z plus, um if I have digamma of z, okay, so plus 1 over z, that's just diagram of z plus 1, right? And where it comes from is, okay, so basically we have gamma of z times z is equals to gamma of z plus 1, right? We can take log in both sides, and then you will have log of gamma of z plus log of z equals to log of gamma of z plus 1, yeah? That's why, and now if I differentiate this will just be digamma of z plus 1 over z is digamma of z plus 1, yeah? Now if we use the same thing, but there's a little problem over here. Okay, wait. Oh, okay. Actually, I was the one who made the problem over here. Okay. Here, the first term is not x plus 2, right? It's actually, I'm sorry, guys. Why am I doing a lot of these mistakes? Okay, the thing is, first of all, these results are the sum when it goes from n equals to 1 to infinity, right? But like the first term is not there, so I should remove the first term. And first term will have x plus 1 and 1 minus x. And so I should be removing this. I don't know. Okay, so now again, after using this property that I just mentioned over here to you guys, so we know that this is gonna become diagamma of 2 minus x, right? Because yeah, this is just g plus 1, and then minus diagamma of this will become 2 plus x, right? Just 1 is added, right? And then dx. Now if I take the integral, we know that this is just derivative of log of gamma, so this becomes log of gamma of 2 minus x, but x has a negative sign in front of it, so divide by that, minus log of gamma of 2 plus x, right, from 0 to 1. And now when x is 1, this becomes log of gamma of 1 by negative 1 minus log of gamma of 3, right? And then now after that, this has already minus sign, so that becomes plus log of gamma of 2, and then that will also become plus actually, right? And that becomes log of gamma of 2. Now gamma of 1 is also 1, gamma of 2 is also 1, so this goes to 0. This is minus ln of gamma of 3 is 2. This is also 0 because the ln of 1 is 0, and this is also 0. So we see that answer is negative ln of 2. So that's it, guys. I definitely made some mistakes, but we had the solution right now. The idea was, first of all, to express zeta function in terms of infinite series. Then we could take it to log, and after that we could actually introduce an integral, and then we could do the sum by first breaking into parts of a fraction, and then using diagonal function, and then again using that properties of diagonal function, and then again integrating diagonal using log, and that solved the problem. So that was it, guys. I definitely hope you enjoyed the problem, even though I made quite a few mistakes. I think writing Anna's K was the most funniest mistake, I think, because that might have confused you a lot. I'm sorry for that. But that was it, guys. Hope you enjoyed the video. Thanks for watching, and I look forward to seeing you in the upcoming video too.